Hello, welcome back once again. Today we have an amazing problem, right? Have you seen something like this before? Integrating the Lambert W function of x. Isn't that not amazing? But the problem here is, how exactly are we going to approach this problem? Let's start with a substitution. So we're going to let the Lambert W function of x equals u, right? We know that this Lambert W function is the inverse function of x times e raised to the power of x. Therefore here, x is going to be equal to u times e raised to the power of u, right? Okay, now let's differentiate both sides. So the left hand side will have dx, and at the right hand side we're going to make use of the product rule, right? So first we start with the derivative of u. The derivative of u is 1, then multiply by e to the power of u. Then we have plus, then we have u multiplied by the derivative of e to the power of u. Remember, I have a name for this guy. And what's that name? This guy is the stubborn guy, right? You know about that? So he's a very stubborn guy. Therefore, its derivative remains the same. So we're going to have u times e to the power of u, and then we have our du, right? Do you get that? Okay, now our integral of the w of x is going to be equal to, in terms of u, the integral of w of x is u, remember? Then our dx is equal to e to the power of u plus u times e to the power of u, and then we have our du. Then we split, we get the integral of u times e to the power of u plus u times e to the power of u will give us u squared times e to the power of u, and then we have our du, right? Okay, now we have two different indefinite integrals. So we have the first one, the integral of u times e to the power of u du, right? And we have the second one, oh sorry for this. So we have the second one which is the integral of u squared times e to the power of u, then du, of which we're going to solve this using the integration by parts method, right? So here, let's set u equals u. Then differentiating both sides, we get du is equal to 1 times du, right? And then we have to set v equals e to the power of u, the integral of e to the power of u, which is same as e to the power of u. Then our dv is going to be equal to e to the power of u, then du. And again, for this right hand side, our u is going to be u squared. Differentiate both sides, we get du is equal to 2u du. Our v is going to be the integral of e to the power of u, which is same as e to the power of u. Then our dv will be e to the power of u, and then we have our du. Interesting, right? Okay, cool. Now, using the integration by parts formula, remember we're going to have uv minus the integral of v du. So our uv at the left hand side is u times e to the power of u, then minus the integral of v, which is e to the power of u, and then we have our du. Don't forget that the two integrals are being added, right? So we have a plus. Then at the right hand side, we still use the integration by parts formula, uv, that will be u squared times e to the power of u, as you can see it here, uv. Then minus the integral of v, which is e to the power of u, times du, which is 2u du. And here we have u times e to the power of u, then minus the integral of e to the power of u is e to the power of u, right? So remember that this one right over here, stands for the integral of u times e to the power of u. Do not forget that, right? So from here we can still just put in this result, right? Okay, so you will understand what I'm talking about. So let's just continue, okay? So here now we're going to have plus, so this will be u squared times e to the power of u, and then we have minus 2 multiply by, now you can see we have it here, u times e to the power of u, and then our du. So remember what I said earlier. So this is going to be u times e to the power of u minus e to the power of u plus u squared times e to the power of u, then minus 2 into bracket, then this value, right? Which will give us u times e to the power of u minus e to the power of u, and then we have our constant of integration. So here we have u times e to the power of u minus e to the power of u, then plus u squared multiplied by e to the power of u minus 2u e to the power of u, and then plus 2e raised to the power of u plus c. Then we need to simplify, right? So first we have this one, which is u squared times e to the power of u, which we can write as u into bracket u times e to the power of u. I have idea for this, okay? So let's just continue. So here we have negative e to the power of u plus 2e to the power of u, which will give us positive e to the power of u, right? And here we have u e to the power of u multiplied by minus 2u e to the power of u, which will give us negative e to the power of u, and then we have our plus c. Now let's recall back. So it's very nice to always recall, right? So remember that w of x is equal to u. Did you forget that? And again, x is equal to u e to the power of u. So we can see this is x, right? And this one here is the w of x. So we get here x multiplied by the w of x. Did you get the idea? Then plus e to the power of u will be e to the power of, oh sorry, I think we missed something somewhere. Oh, sorry for that, I just realized that. Okay, so this place will be u e to the power of u. So minus u times e to the power of u. So thank God I just realized this, right? So that is a very silly mistake. Okay, so this place e to the power of u will be e to the power of the w of x, and then minus u e to the power of u is our x, and then plus c. So this right over here is the integral of the w of x dx. Amazing, right? Please, if you really enjoyed this video, kindly support by subscribing. Also like, comment, and share.